Hello, welcome to your first review podcast for our 7th grade science class. I'm Mrs. Olson, and I'm going to take a few minutes and review our objectives for our scientific processes unit. There are 4 total. We're going to take them one at a time. The first objective deals with observation versus inferences. An observation is a fact, something that you can tell or measure or determine based on seeing, hearing, touching, tasting, smelling. You use your 5 senses. On the other hand, an inference is a guess or a conclusion. You're assuming something, you're predicting something, you think something, but you can't observe it directly. So for example, that plant died due to lack of water is an inference. I am guessing that that is the cause of the death. The dog is about 1 meter long is an observation. I can physically measure with a meter stick the length of the dog. It's raining would also be an observation. I can physically see and feel the rain falling. She is tired would be an inference. I'm guessing that that's why she looks the way she does. I am assuming that she's tired. So for this objective, you should be able to give me examples of both kinds of statements, or if I give you a statement, you should be able to tell me whether it's an observation or an inference. Our second objective deals with the 2 different kinds of observations. They are qualitative and quantitative. Qualitative involves adjectives. There are no numbers involved, so you're describing what you see. For example, lobed leaves, heavy book, smelly ammonia. On the other hand, quantitative is a measurement using some sort of number. There are 3 lobed leaves, a heavy book that weighs 5 kilograms, 3 milliliters of smelly ammonia. Those words look really similar, but if you look at the beginning portion, you might find a clue. I like to think of quality for adjectives and quantity for numbers. You should be able to identify statements, whether they're qualitative or quantitative. You should also be able to give me examples of things that are a qualitative observation or a quantitative observation. Our third objective has to do with the scientific method. Here are the basic parts. There's the question, background research, hypothesis, procedures and test, analysis, and conclusion. The question portion refers to what are you trying to test? What answer are you trying to come up with? Your research is what information did you gather or observation you make before you even got started to help you figure out your experiment or to help you design it. Your hypothesis is what do you think is going to happen based on what you researched or you observed. Your procedures in the test is the explanation or the list of what you do to try and solve that question. Once you've done your experiment and you get your data, you're going to analyze it. You'll take your data and put it in graph form or chart form or in a method that helps you make sense of it and to see patterns. Then you use that to make a conclusion or an inference based on your data. Those are essentially the parts of the scientific method. In an experiment, you only want to change one variable at a time. You want to be very specific in your procedures so that anyone could follow your steps. It's a method to answer questions in science, but it's not the only one. It's flexible. You're going to gather data, make your observations, and then make your conclusions or your inferences. If you're still a little confused on the scientific method, go back to our website and use the PowerPoint that we watched in class to help you review the parts one more time. So let's look at a story and see if you can identify the parts of the scientific method. Harry and Ron want to know how much powdered dragon claw they need to be smarter than Hermione. They decided to take a teaspoon of powder on Monday and then ask Hermione questions until one person out of the 3 of them was the only one that knew the answer. They were going to repeat it until one of them were smarter than Hermione. They hypothesized that it would take about 4 teaspoons. They doubled the amount of powder each day, and here are their results. On Monday, with 1 teaspoon, Hermione was the one that knew all the answers. On Tuesday, with 2 teaspoons, Hermione. On Wednesday, with 4 teaspoons, Hermione. On Thursday, with 8 teaspoons, Hermione. And on Friday, with 16 teaspoons, it was Hermione as well. So their conclusion was that their data did not support their hypothesis. They need to test again after they do some more research, and they need to buy some more powder. So let's take a minute and see if you can identify the question, the hypothesis, and the conclusion from the story. The question they wanted to solve was how much powdered dragon's claw will it take for Harry to be smarter than Hermione? The hypothesis was 4 teaspoons. And their conclusion was that their data didn't support their hypothesis. They need to test again after more research and buy more powder. Our last objective, objective number 4, has to do with variables and graphing. The independent variable is what you change in an experiment or what you're testing. You should only have one independent variable in an experiment. The dependent variable is what you're measuring or the data that you're gathering in an experiment. So think dependent and data. The control is what you keep the same or what you don't change. And that should be everything else in an experiment. So let's go back to our Harry, Ron, and Hermione story. Take a minute and see if you can identify the independent, the dependent, and the controlled variable in this story. Independent variable is the amount of powdered dragon's claw they need. That's what they're testing, that's what they're deliberately changing. Remember, 1 teaspoon, 2 teaspoon. The dependent variable is who knows the answer to the question when the others do not. Is it Hermione, is it Harry, or is it Ron? And the controls are everyone is asked the same questions, they're testing the same 3 people, Ron and Harry are getting the same amount of powder each day. When graphing, we learned an acronym to help us remember which variable goes on the x-axis and which variable goes on the y. We learned DryMix. Dry stands for dependent or responding variable on the y-axis, and mix stands for manipulated or independent variable on the x-axis. Let's take a look at a graph and see if you can identify which is the dependent and which is the independent variable. So using the acronym DryMix, we can remember that the dependent is on the y-axis, so in this case it's severity. Independent is on the x-axis, and in this case it's where the banana was stepped on. Thank you for listening. I hope this helped. We took a few minutes to go over each of the 4 objectives for this scientific processes unit. As always, if you need extra help, please come in and ask. I look forward to seeing how much you've learned on our test that's coming up soon.